So Andy, since the inception of CubeSats, they've operated in low Earth orbit. Now we're looking to taking them into deep space. Why now?
CubeSats have spent almost 2 decades developing the technology to show what they can do in low Earth orbit. Education missions, technology demonstrators, science, even commercial these days. Well, people have started to ask, what could we do with these low-cost platforms beyond the Earth? Start to explore the solar system and go to those focused mission areas that are too risky or not worth going to with a much larger mission there. MarCO is a technology demonstrator mission, taking what we've learned from low Earth orbit and really building it out to the deep space environment. How do we maneuver? How do we communicate? How do we navigate away from the Earth? When we head out to Mars, we're going to be proving all these technologies along the way. And then we'll be able to support the InSight mission as it goes through entry, descent, and landing.
Talk about some of the challenges that you've had to overcome to get MarCO to Mars.
Well, it was one of the quickest spacecraft that we've ever had to develop for a Mars program on here. The original timeline was only 14 months from PowerPoint slides to launch. Along the way, we had to develop new technology. How do we make a radio small enough to talk to massive dishes around the world and yet fit into a box only about that big? We've had to work to maneuver in deep space along the way, the propulsive type technologies on here, and to orient ourselves, and then just survive the deep space environment. CubeSats in low Earth orbit, they've gone up to about 800 kilometers above the Earth. We're traveling 158 million kilometers on the way to Mars, a very large scale difference there.
What is the goal for the use of MarCO around Mars?
Really, MarCO is going as a flyby mission to Mars, but it's getting there at just the right moment, just that second, when it can collect data from the InSight lander, going through entry, descent, and landing, and relay that data back to Earth. It's what we call a carry-your-own relay, where InSight is able to launch with MarCO, and then they fly independently to support the mission as it's going through EDL.
What does the success of this demonstration mission mean for missions going forward?
Even the missions that are upcoming next for the deep space environment with CubeSats on SLS EM1, there are 13 missions out there that rely on the technology that MarCO is showcasing, including primarily the radio that's on board. That same radio is on many of those 13 CubeSats and allows them to communicate and navigate in the deep space environment.
Now, ever since we've been covering CubeSats, there have always been students involved, from high schools to college, working on their own CubeSats. Are there any working with MarCO?
Absolutely. Morehead State University will actually provide us an in-flight demonstration of our relay, broadcasting out a UHF message and allowing us to relay it back to Earth as a test prior to us going to Mars. Cal Poly San Luis Obispo is providing data analysis throughout the operations area, all the way out to Mars and back. In fact, we even had students design boards for MarCO itself that are now going to fly out to Mars and provide some of our critical functions. MarCO allows students to develop technology and to develop missions that will provide very focused opportunities into the future. My dream is that someday a student will learn how to develop CubeSats during their undergrad, come up with an idea during their master's and launch it. By the end of their PhD, will be presenting results from that spacecraft during their thesis on there. That is an entirely new way to explore, and one that NASA is very much looking forward into doing in the future.